So we're going to be working on some Chapter 7 practice problems. And as you can see here in the directions, what I'd like you to do is go ahead and copy down the problem, pause the video, do your own work, and then go ahead and check your work by playing the video, and we're going to do that a few times. So I'm going to do this section by section. I'm going to start with section 7.1, and this is going to be our first question. And we are going to write an inverse equation given x is equal to -4 and y is equal to -6. Okay, so we are going to set this up as -6 is equal to your constant over -4. We're going to solve for that constant by multiplying by -4. And we get that 24 is equal to a, meaning that our equation is y is equal to 24 over x, and this is our final answer right there. Okay, let's move on to number 2. We're figuring out how these equations are varying, so I'm going to give you all the equations to start with. xy equals 5, 5y equals 6x, 15 equals x over y, and y minus 3 is equal to 2x. And the question is, how do these relationships vary? Okay, so we need to go ahead and solve for y on them. So I'm going to put some different equations up here. And we know that this one is y is equal to 5 over x, where x is in the denominator, meaning that this is an inverse variation. I'm going to divide both sides by 5 on this one, meaning that y is equal to 6x over 5. And x is in my numerator on this one, a slope of 6 over 5, y-intercept of 0. That's a direct variation. This one I actually have to cross multiply a few things. It ends up being y is equal to x over 15, slope of 1 over 15, y-intercept of 0. That's another direct variation. Add 3 to both sides, y is equal to 2x plus 3. That has a y-intercept of 3, so that's neither. All right. Let's go ahead and let's move on to 7.2. Got a little bit of graphing on this one. So for your third problem, we have y equals -1 over x plus 5 plus 2. And I'd like you to go ahead and graph it. Okay, so first thing that I like to do on this is kind of set up and figure out where my asymptotes are going to be. That way I can go ahead and set up my coordinate plane. And I know that my asymptotes are going to be at -5 for my vertical asymptote. That means I can go ahead and kind of, there we go, -5 and 2. So I'm going to drop this y-axis down a little bit. Sorry, my x-axis down a little bit. And then for my asymptotes, I'm going to go ahead, I'm going to do it in highlighter, but feel free to do it in a dashed pencil if you'd like. I'm going to make this a little bit smaller. And I know that my vertical asymptote is at 2. So there's my vertical asymptote, and my horizontal asymptote is at -5. Okay, so there's my asymptotes. I'm going to pull this one over a little bit. There we go. And now I also have a flip on this one with this -1 up here. So that means that I'm going to, I would normally go over 1, up 1, but now I'm going to go to the left 1 from my asymptote up 1. There's my first point. And from here, I always kind of like to draw these halves so that I can get a little bit better idea of how my curve goes. And we get really close to those asymptotes. On the other side, again, I like to draw these halves so that I have a nice clear curve going from there. And why don't we go ahead and also state our domain and range. I know that my domain is that x cannot be -5. If you're wondering what that looks like in interval notation, we just go ahead and use that open parentheses at the -5. My range is that y cannot be 2. And again, this interval notation is from -infinity all the way up to 2, not including 2, and 2 to infinity. Okay, I have one more for you to graph. We are going to go ahead, I'm going to put this in function notation, and we're going to say f of x is equal to 3x minus 2 over x minus 4. Okay, what I actually want to do for this one is I want to start with my domain and range. So I'm actually going to switch over colors for this one. And for my domain, I know that that is my bottom part here. So I know that for my domain is that x cannot be 4, and this happens to be my vertical asymptote as well. Okay, so for that one, and then I'm going to talk a little bit about my range or my horizontal asymptote, and that comes from this number over this number. So if I'm looking for my range, I know that y cannot be 3 over 1, also known as 3, and this is my horizontal. Okay, so now that I have those asymptotes, I can go ahead and I can set up this set of axes, and I actually am going to shift it over quite a bit because we are working in the positive parts with 3 and 4. There we go. And then from here, I'm going to go ahead, I'm going to do my asymptotes in highlighter. Again, you are totally welcome to do this with a dashed line. Switch over to blue so you can see this. 1, 2, 3, 4. Okay, so then we're going to, from here, now that you have your asymptotes, you would go ahead and you would start plugging in some numbers. Feel free to use a calculator if you need to plug in some numbers. I started with 0, and when I started with 0, I got a half, and I was like, oh my goodness, what? We have a half, and then I plugged in 1, and I have a third, and I was a little bit confused on this one when we started to plug in some numbers. But if you actually end up plugging in -1, you get 1, which is a nice integer. And if you plug in 2, you get -2. Now, here's the thing about these rational functions is that once you kind of have one point, you can go ahead and you can mirror it. And what I mean by that is that, I'll put this in yellow and kind of show what if I'm going over 5, so 1, 2, 3, 4, 5, down 2, so if you go over 5, down 2, from your asymptotes, you also kind of do that on the other side. So what I mean by that is that you would then go over 2, down 5. 1, 2, 3, 4, 5. So you can start to see that it starts mirroring each other. I'm going to get rid of those marks. I'll keep that one up there for you. And from here, you can make a nice curve through your points. And the stretch on this one ends up being really big. But you can also do it. I'm actually going to end up going into my other graph. I'm sorry on that one. 2, 3, 4, 5. On your other side as well for this graph. So it ends up having a very large stretch on this one. Now, I kind of want to go ahead and I want to test my stretch and see if I did this correctly. So I'm going to turn my equation into my transformation form. And how I'm going to do that is I'm going to work with division. So I have 4 in my divisor box, my coefficients, 3 and -2. Bring down the 3, that's 12. This is a 10, meaning that my equation would be f of x is equal to my remainder, so 10 over x minus 4, and then plus what I was left over with there, because we're changing it into an improper fraction. And that makes sense for this. I have a stretch of 10, which makes sense for my equation. Okay, let's move on to 7.3. So question number 5, I'm going to ask you to do x squared minus 13x plus 40 over x squared minus 2x minus 15 divided by x squared minus 5x minus 24. Okay, so I'm going to factor and flip all in one step. So I have x, I'm looking at the factors of 40 that add to -13. That's x minus 8, x minus 5 over factors of -15 that add to -2. I have x minus 5 and x plus 3 times, I'm going to flip this one over here, and I have x minus 8 and x plus 3, and we have a whole bunch of things that are going to start canceling out. So I have an x minus 8 and an x minus 8, and then I also have an x minus 5 and an x minus 5. That just leaves me with 1 over x minus 3 squared, but I have to state that x cannot be 8 and x cannot be 5 on this one. Okay, so we're going to actually jump all the way to 7.4. We're on question 6, and we have some addition. So I have 5 over 6x plus 18 plus x minus 4, x plus 4 over 2x. Okay, first step that I need to do is factor this denominator down here. So I have 5 over 6 times x plus, not 18, plus 3 plus x plus 4 over 2x. And I need to figure out what my lowest common denominator is going to be for this one. So one of the things that I like to do, especially when I have numbers here, is that I'm going to cross out this 6 and I'm going to make it a 2 times 3 so that I can easily see that my denominator is going to be 6, or 2 times 3, times x plus 3. And then I'm going to have that on my other side as well. 6x times x plus 3. So now I just need to figure out what I need to multiply by. So I need to multiply my left side by x over x because that's what I'm missing, meaning that I'm left with a 5x. And on the other side, I have the 2. I'm missing the 3, so I need to multiply by 3. I also need to multiply by x plus 3. And when you multiply this all out, you get 3x squared plus 21x plus 36. Add up everything, which actually just ends up being your 5x plus 21. Your final answer is 3x squared plus 26x plus 36. I definitely can't factor that. There's no GCF or anything. Over 6x times x plus 3. We didn't cancel anything out, so we don't have to state any domain restrictions. Last section is 7.5. And we are on number 7. We got some solving. So we have 8 times x minus 1 over x squared minus 4. We're going to set that equal to 4 over x plus 2. And this one is set up for cross multiplication. I'm going to show that we're doing 4 times x squared minus 4. I'm going to distribute on the top, so I have 8x minus 8 times x plus 2. When you multiply all this out, you get 4x squared minus 16 is equal to x squared. We have plus 8x minus 16. It's a quadratic. We need to move things to one side. I'm going to choose the right side to keep things positive. 0 is equal to 4x squared plus 8x. This one factors nicely with a GCF. Left with x plus 2. And we have 4x is equal to 0 and x plus 2 is equal to 0. So when you solve, you get x is equal to 0 and x is equal to negative 2. Oh, but I know from this one with my domain, I can't have a negative 2 there. I also can't have a negative 2 here. So I'm going to go ahead, I'm going to cross off this one. But when you plug in 0, it ends up working out for you. Okay, our last problem is going to be another solving one. 2 over x minus 3 plus 1 over x is equal to x minus 1 over x minus 3. And this one, you are set up so nicely to fraction bust. So I have x times x minus 3. A few things are going to start canceling out here. This x minus 3 on the first one, which leaves me with 2x, plus the x cancels out on the second one, x minus 3. And my very last one, the x minus 3 cancels out, so I have x squared minus x. It's another quadratic. You could go ahead and combine like terms on one side, but I find it easier sometimes just to kind of all combine like terms on one side so that we see that we have 0 is equal to x squared, and now we have minus 4x plus 3, and again this one factors nicely, so we have x and this is a negative 3 and x times or minus 1. Set both of them equal to 0 and solve so that x is equal to 3 and x is equal to 1. Uh-oh, again I run into that domain restriction here. So I'm going to go ahead, I'm going to cross off this guy. But when I go ahead and I plug in one, it works out nicely. And you are all done.